This discussion examines AI safety, AI alignment, the frameworks used to manage them, and the debates around their limits. AI, safety, and alignment are presented as critical areas of discussion for making sure artificial intelligence benefits humanity while minimizing risks. The topic involves understanding practical challenges, exploring philosophical debates, and critiquing existing approaches. It connects ethics, technical design, and governance in one shared problem. 02, 03, 04, 05. AI safety refers to measures, principles, and frameworks designed to ensure artificial intelligence systems operate within ethical and legal boundaries. It also aims to minimize harm to individuals and society. Another core aim is avoiding unintended consequences during operation. The material highlights 3 core challenges in AI safety. Unintended consequences can emerge from programming flaws or unforeseen interactions with the environment. High-stakes applications in healthcare, defense, and finance can produce catastrophic outcomes if mishandled. Safety must also scale as artificial intelligence becomes more complex. In healthcare, biased training data can lead to incorrect medical advice. In autonomous vehicles, crashes raise ethical programming dilemmas, including how to prioritize pedestrian safety and passenger safety. AI safety is described as critical for responsible development and deployment. It helps minimize harm while maximizing benefits. It also addresses risks, establishes ethical frameworks, and promotes trust in artificial intelligence technologies. 02, 03, 04, 05. Risks come from unintended consequences and misuse. Systems may behave unpredictably because of flawed programming, inadequate testing, or unforeseen interactions. They can also be exploited for misinformation, cyber attacks, and mass surveillance. Examples include deepfake identity fraud, political manipulation, and attacks on critical infrastructure. A key ethical challenge is encouraging innovation without compromising safety. The material points to regulatory frameworks that support development while maintaining safeguards. It also highlights public-private partnerships as a way to develop and enforce safety guidelines. 4 design principles are emphasized. Transparency means systems should be understandable and explainable. Accountability requires clear responsibility for outcomes. Fairness means avoiding bias and ensuring equitable treatment. Privacy focuses on protecting user data and following data protection laws. In healthcare, these principles support unbiased decisions and patient confidentiality. AI alignment addresses the problem of ensuring that artificial intelligence objectives match human values, intentions, and societal goals. The material identifies value specification as a challenge because abstract human values are hard to translate into precise objectives. Dynamic preferences and superintelligent systems make the problem even harder. Goals must match intents. Smarter systems raise risk. Supporters argue that alignment is critical for helping advanced systems benefit humanity and minimize risks. They say it helps avoid existential risks, promotes fairness, accountability, and trust, and encourages international cooperation. Critics argue that alignment can focus too much on hypothetical risks and distract from bias and misuse happening now. 02, 03, 04, 05. The orthogonality thesis suggests that intelligence and goals are independent. The implication is that a highly intelligent system could still pursue harmful objectives if it is misaligned. This makes goal alignment a philosophical and technical challenge, rather than something guaranteed by intelligence alone. A major challenge is balancing competing ethical principles in real-world situations. Human feedback guides ethical AI design. Several techniques are presented for aligning systems with human values. Human in the loop adds human oversight to decisions, such as intervention in complex driving scenarios. Reinforcement learning from human feedback trains models using explicit feedback. Ethical design principles embed fairness, transparency, and privacy into algorithms. The case studies show different alignment methods in practice. OpenAI ChatGPT training used reinforcement learning from human feedback to improve appropriate responses and reduce harmful outputs. Waymo used human oversight in critical scenarios. Google Fairness work reduced bias in hiring tools. IBM Watson in healthcare relied on multi-stakeholder collaboration. Precautionary measures support safety by design in high-stakes settings. Collaborative efforts such as OpenAI, the Partnership on AI, and the European Union Artificial Intelligence Act promote cooperation. Explainability tools improve trust and accountability. Yet ambiguity in human values, bias from training data, and reactive responses remain serious limits. Current approaches have notable strengths. The material reviews 4 popular methodologies. Human in the Loop provides continuous human oversight during decision-making. Reinforcement learning from human feedback uses explicit human input to shape behavior. Explainable artificial intelligence aims to make decisions understandable. Ethical design embeds fairness, accountability, and transparency into development. Human oversight reduces risk in high-stakes scenarios, yet scaling it is difficult. Each framework offers value, but each has weaknesses. Reinforcement learning from human feedback can align behavior effectively, but it depends on feedback that may be inconsistent or biased. Explainability builds trust, while complex deep learning models remain hard to explain. Implementation case studies reveal both promise and limitation. IBM Watson for oncology supported treatment recommendations, enhanced diagnostic accuracy, and prioritized patient outcomes, but depended heavily on data quality and sometimes lacked explainability. Tesla Autopilot improved safety in some scenarios and allowed manual override, yet struggled with edge cases and ethical dilemmas. The material lists several successful examples. Google Fairness work aimed to minimize bias in advertising algorithms. DeepMind AlphaFold showed safe use of artificial intelligence in protein structure prediction. OpenAI refined ChatGPT to reduce harmful or biased outputs. Amazon used fraud detection systems to improve financial safety by identifying fraudulent transactions. International collaboration is presented as essential because artificial intelligence systems often operate across borders. Harmonized regulation can reduce fragmentation, support knowledge sharing, and align ethical principles. Key initiatives include the European Union Artificial Intelligence Act, the Partnership on AI, the United Nations Educational, Scientific, and Cultural Organization Recommendation on AI Ethics, and the Organization for Economic Cooperation Principles. 020300405. This fragmentation creates compliance difficulties and can weaken safety efforts. The overall message is clear. Safer and more aligned systems require transparency, oversight, collaboration, and continuous refinement.